Welcome back, students. What we'll do today is our second day for the final week of review for the AP exam. What I did was I clipped a question right out of the old AP exams that was based on linear regression. So go ahead and read through this to get a sense of what's going on here, and I'll go through the key concepts. Feel free to pause this and make sure you read thoroughly. Okay, welcome back. So what we have is a random sample of 67 American beavers. Basically, what you're trying to do is see if the further they are from their home, the faster they will move. That's the theory, okay? So the explanatory or the X variable is the distance to the lodge, how far away they are. And the response variable is the speed in which they move in meters per hour. Okay, so here goes. Now, is the linear model appropriate to use for these data? Justify a response by referencing the residual plot. So what we look at here is a residual plot that has no curved pattern. Okay, if a nonlinear model was more appropriate, it would have a clear curved pattern to this. Okay, so you'd have values either lower than average values of X. They would have residuals that are above. Then in the middle, they would be below the line, below zero, so negative residuals, and then back to positive. It would be very clear. What's going on here is it's random. It's up and down. It's clearly random. There's no curved pattern that's definite. When we get a curved pattern, there's no doubt. And I can show you one of those after this. So what we do with the linear or the residual plot, this is not the scatter plot. The scatter plot would look very different. This is the distribution, the scatter plot of the residuals. This is how they would look. So these are the deviations, the vertical deviations from the line, okay? Now, is the linear model appropriate to use for these data? The answer right here that I'm going to type up is the residual plot. So you're going to notice what I do is I try to reference course content first for the exam, and then I turn it to the specifics of the question they gave me. So the residual plot, we're going to start with this. When the residual plot is random, the linear model is appropriate for the data. When the residual plot shows a clear curved pattern, a nonlinear model is more appropriate. Okay. So what I've just done is, instead of answering the question they asked, I shared with the score that I have course content knowledge. Now, right away, they've got to give me a P because I'm clearly stating, hey, I know what's going on here. Now, to get the E score for this portion of it, what we want to do is now turn it into this particular question, okay? And then here's how we save ourselves. If we disagree, but let's say there was a clear curved pattern in the score's eyes, it's not, but let's say there was, well, then we at least have expressed course content knowledge, which saves us in getting at least a P, okay? So that's what's going on with expressing course content knowledge. All right, in this case, scatter or the residual plot is random. So the linear model, make sure we answer the question, is appropriate for these data. All right, there's an E for us right away. Okay, so this is another way to, instead of making you type all the scores into your calculator, typically what's going to happen on the AP exam is they're going to go ahead and put it into one of their mini tab or whatever their computer program is, and they're going to give you a computer output however they want. And what we have to do is we have to figure out what it's saying basically. So the intercept, that's the y-intercept. Sometimes they'll use the word constant here, constant or the intercept. That would be this one. Okay, that's your y-intercept. Distance, they're not going to tell you that's the slope. So the distance to the lodge is the explanatory variable. That's always what they use for the slope. Okay, it's the explanatory variable. They're not going to say x value. They're not going to say slope. You just have to know that that's what's going on here. Now, this is the estimate for the slope, and this is the error. That's the sampling error for that particular parameter. Okay. So if you remember t-scores, right? The t-score for this came out 17.7, so the p-value is less than 0.001. From what we learned in the course was S is how much we expect the typical residual to be. It's almost like the standard deviation of the residuals. Okay. The R squared value, remember, what we do is we take the square root of that, and since the slope is positive, it's going to be about positive 0.9 something, really close to 0.9. So that's going to be the correlation coefficient, which we'll get to in a minute. But that is your slope. That if you take the square root of that and use the same sign of the slope, you'll get your correlation coefficient. Okay, now the computer output from the regression analysis and the box plot of the residuals. So this is talking about the distribution of the residuals themselves. So it's a little bit concerning, but not terrible. This should be roughly symmetric, centered at 0. My concern is that it's a little bit above 0, but not terribly. I don't think it's so far above 0 that we have any concerns. So this is the reliability that is discussed here. Okay. Identify the intercept of the least squares regression line. Okay, here's where that is. So this and interpret it. Okay, the intercept. Interesting. Usually they want the slope. You know what? I'm going to do slope afterwards, but my intercept for this your regression model or line of best fit. You're seeing a lot of terms here. They said least squares regression line. All of those are really the same thing. Okay, all these phrases, linear regression model, line of best fit. I don't know what they're going to use in context. They're going to see how many of these there's 3 or 4 of them. So any one of those is the appropriate expression for that. The y-intercept for this regression model is negative 16.462. Now, bigger in this case is the interpretation of that. Okay, so this is where the y-intercept is where x equals 0. And this is where the model predicts the y value to be when the x value is 0. That's a little better. What I really like about this setup, believe it or not, in the 2020 is AP exam is the fact that you can type, you can edit very easily when you can type. So kind of interesting. It might be something to consider in the future. So, okay. So now what I did was I explained course content, which again gets me a P. Now I will specifically give the context of this question. Okay. So in this particular case, it means that when the beaver is at the lodge, right? 0, what is it? How many, is it meters? 0 meters. Meters from the lodge. Beaver is expected to move at negative 16.462 meters per hour. Of course, the beaver cannot move a negative speed. Interesting. Yeah. But that is what the model predicts. Okay, that's basically it. Now the other parts, I typed this up already. This is not part of what you would say. Okay, so the other parts of the question that I did not put up here are on chapter 9. So this is the end of the chapter 2 content. Chapter 9 is not an exam this year, so I just left it off. Now, what I want to do is talk more about, I want to give you some more ideas in case this comes up on the final. This is probably the last time we'll go over linear regression before the exam. So I really like that they asked us to interpret one of the, well, in this case, it's a statistic, okay? There's 2 other things they could ask us to interpret. If they asked us to interpret the slope, state and interpret the slope. Okay, so I'm just going to create another problem here to solve. Okay, and let's say that was actually C, right? Let's say that was part C. State and interpret the slope in context. It's always in context, so we got to work on that. Okay, so first, let's give course content knowledge. Okay, so as X, what we would say slope is for every unit we increase X value, we predict blank units of increase or decrease, depending whether it's positive or negative slope, units in the Y direction, big direction. Okay. Now, for instance, in this case, slope is, now it's always the variable in context, so the X variable in context, the explanatory, is 0.849, which means for every meter further from the lodge, the beaver is, we predict the speed beaver's movement to increase by 0.849 meters per hour. So now that's the explanation of what's going on in context. Okay, so the last possible interpretation is state and interpret. State and interpret the correlation coefficient. Okay, so first, R squared is, does it say percentage? Oh, usually it'll say 81.9%. I'm going to write that because it's usually a percentage. So R equals the square root of 0.819. Okay. Now, it's positive because the slope is positive. So while you're doing your work, it really should say plus or minus. Usually it's plus or minus, the square root of that. Now we choose positive. It is positive because the slope is positive. Now, let's just quick. I'm thinking it's around just over 0.9. So the square root of 0.819, have to make sure you turn that into a decimal, is 0.905, right? Yeah, 9050. So R equals, we're going to take positive 0.905. This shows a strong positive linear relationship between, now you have to make sure that you put context in here, okay? The distance beaver is from the lodge in meters to the speed at which the beaver moves, and that's in meters per hour. Okay, so hopefully this helps you in case they ask you to interpret one of the other variables. You're ready for interpreting the y-intercept from this one, but they could ask you to interpret the slope. They couldn't ask you to interpret the correlation coefficient, okay? The coefficient of determination, or R squared, right, is right there. You got to work to turn it into a coefficient or correlation coefficient. Hopefully this helps. Please check it out, and good luck on the AP exam.